7 very powerful nuclear explosions caught on camera. How powerful are nuclear explosions? The US Trinity test in 1945, the first ever nuclear detonation, released around 19 kilotons of explosive energy. The explosion instantly vaporized the tower it stood on and turned the surrounding stand into green glass before sending a powerful heat wave across the desert. Since then, the global nuclear stockpile has multiplied, and when geopolitical tensions rise, the idea of a nuclear apocalypse understandably causes widespread concern. But despite their catastrophically large effects, the science of how nuclear weapons work is atomically small. As the Cold War escalated in the years after World War II, the US and the Soviet Union tested bombs that were at least 500 times greater in explosive power. This infographic visually compares the 7 largest nuclear explosions in history. So come and let's watch it. Welcome to our channel Space Venture. In today's video, we're going to talk about some of the largest nuclear explosions in history. After exploding, nuclear bombs create giant fireballs that generate a blinding flash and a searing heat wave. The fireball engulfs the surrounding air, getting larger as it rises like a hot air balloon. As the fireball and heated air rise, they are flattened by cooler, denser air high up in the atmosphere, creating the mushroom cap structure. At the base of the cloud, the fireball causes physical destruction by sending a shock wave moving outwards at thousands of miles an hour. A strong updraft of air and dirt particles through the center of the cloud forms the stem of the mushroom cloud. In most atomic explosions, changing atmospheric pressure and water condensation create rings that surround the cloud, also known as Wilson clouds. Over time, the mushroom cloud dissipates. However, it leaves behind radioactive fallout in the form of nuclear particles, debris, dust, and ash, causing lasting damage to the local environment. Because the particles are lightweight, global wind patterns often distribute them far beyond the place of detonation. Number 1. Ivy Mike, 1952. 69 years ago, a new type of cloud was the focus of the scientific research. The mushroom cloud produced by the Cold War atomic tests, Ivy Mike, which took place on November 1, 1952, was the first full-scale test of a hydrogen bomb, equivalent to more than 10 million tons of TNT. It obliterated the small island of Illujalab. The rising fireball was accompanied by a spectacular display of lighting. This unusual nuclear lightning was a side effect of the transient electromagnetic pulse from the nuclear blast. Afterwards, USAF F-84 Thunderjets with sampling equipment flew into the stem of the boiling mushroom cloud. The first made it through without difficulty, and the other 2 hit severe turbulence caused by the tremendous updraft and lost control. After recovering their planes, pilots Bob Hagen and Jimmy Robinson found their navigation instruments and radios had been disrupted by the electromagnetic pulse. They could not find their refueling aircraft. The 2 pilots ran out of fuel heading back to Eniwetok Air Base. Hagen glided down to a safe landing, but Robinson dished in the sea and drowned in the lead-lined west supposed to protect him from radiation. The US, UK, and the Soviet Union signed the Partial Test Ban Treaty in 1963, ending their above-ground tests and this type of hazardous meteorology. Number 2. Castle Romeo, 1954. Castle Romeo was the code name given to one of the tests in the Operation Castle series of American nuclear tests. It was the first test of the TX-17 thermonuclear weapon, the first deployed US thermonuclear bomb. The so-called Runt device was a weaponized dry fusion bomb, using lithium deuteride fuel for the fusion stage of a staged fusion bomb, unlike the cryogenic liquid deuterium of the first-generation Ivy Mike fusion device. It was detonated on March 27, 1954, after several delays at Bikini Atoll of the Marshall Islands, on a barge moored in the middle of the crater from the Castle Bravo test. It was the first such barge-based test, a necessity that had come about, because the powerful thermonuclear devices completely obliterated the small islands in which they were set off. Like the Bravo test, it ran away and produced far more than its predicted yield, and for the same reason, an unexpected participation of the common lithium-7 isotope in fusion reactions. Although it had been predicted to produce a yield of 4 megatons with a range of 1.5 to 7 megatons, it produced a yield of 11 megatons, the 3rd largest test ever in the US. Like the Ivy Mike and the Castle Bravo tests, a large percentage of the yield was produced by the fast fission of the natural uranium temper. 7 megatons of the yield were from this source. Number 3. Castle Yankee, 1954. Castle Yankee was the 5th test in Operation Castle. The explosion marked the 2nd most powerful nuclear test by the US. It yielded 13,500 kilotons, much higher than the predicted yield of up to 10,000 kilotons. Within 4 days of the blast, its fallout reached Mexico City, roughly 7,100 miles away, which is 11,400 kilometers. Number 4. Castle Bravo, 1954. Castle Bravo, the first of the Castle Operation series, accidentally became the most powerful nuclear bomb tested by the US. Due to a design error, the explosive energy from the bomb reached 15,000 kilotons, 2.5 times what was expected. The mushroom cloud climbed up to roughly 25 miles, which is 40 kilometers. As a result of the test, an area of 7,000 square miles was contaminated, and inhabitants of nearly atolls were exposed to high levels of radioactive fallout. Traces of the blast were found in Australia, India, Japan, and Europe. Number 5. Soviet Test Number 219, 1962. Test Number 219 was an atmospheric nuclear test carried out using an intercontinental ballistic missile, ICBM, with the bomb exploding at a height of 2.3 miles, which is 3.8 kilometers above sea level. It was the second most powerful nuclear explosion, with a yield of 24,200 kilotons and a destructive radius of 25 miles, which is roughly 41 kilometers. Number 6. Tsar Bomba, 1961. Tsar Bomba, also called Big Eben, needed a specifically designed plane because it was too heavy to carry on conventional aircraft. The bomb was attached to a giant parachute to give the plane the time to fly away. The explosion, yielding 50,000 kilotons, obliterated an abandoned village 34 miles, which is 55 kilometers away, and generated a 5 to 5.25 magnitude earthquake in the surrounding region. Initially, it was designed as a 100,000 kiloton bomb, but its yield was to cut half its potential by the Soviet Union. Tsar Bomba's mushroom cloud breached through the stratosphere to reach a height of over 37 miles, which is 60 kilometers, roughly 6 times the flying height of commercial aircraft. Number 7. Soviet Tests Number 158 and Number 168. On August 25th and September 19th, 1962, less than a month apart, the USSR conducted nuclear test Number 158 and Number 168. Both tests were held over the Novaya Zemlya region of Russia, an archipelago to the north of Russia near the Arctic Ocean. No film or photographs of the tests have been released, but both tests included the use of 10 megaton atomic bombs. These blasts would have incinerated everything within 1.77 square miles of their epicenters, while causing third-degree burns of up to an area of 1,090 square miles. The first atomic blast was a fraction of the size of Tsar Bomba, but it was still an explosion of almost unimaginable size. According to the nuke map, a weapon with a 20 kiloton yield produces a fireball with a radius of 260 meters, making its total width the size of 5 football fields. It would spew deadly radiation over an area 7 miles in width and would produce third-degree burns in an area over 12 miles in width. If dropped over lower Manhattan, a bomb of that size would kill over 150,000 people and produce fallout stretching to central Connecticut. According to the nuke map, the first atomic bomb was tiny by nuclear weapons standards, but its destructiveness is still impossible to grasp. So that is all for today. Hope you enjoyed the video. Do like, share, and hit the bell icon for future updates. See you in the next video.